Section 1.9 is the distance and midpoint formulas, and using those to work with circles. The distance formula. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. The distance formula actually comes from our Pythagorean theorem. If I have 2 points in a coordinate plane, and this point is x sub 1, y sub 1, this point is x sub 2, y sub 2, and if I draw a right triangle there, then this distance on the right triangle is x sub 2 minus x sub 1. The distance up here, I didn't write this very well. Let's put this up a little higher. This distance here would be y sub 2 minus y sub 1. So d squared would be x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's my a squared plus b squared equals c squared. And then if I take the square root, that gives me my distance. I don't need the plus or minus here because distance is always measured in positive units. So that's the derivation of the distance formula. It comes straight from our Pythagorean theorem. And then our midpoint formula, which is the average of the two x values and the two y values. So we can use both of those formulas for a variety of problems, and you should know both of these formulas, distance and midpoint. Circles. And we're going to apply this to our circle. A circle is the set of all points in a plane that are equidistant from a fixed point called the center. That's why that distance formula is going to come in. The fixed distance from the circle's center to any point on the circle is the radius. So, if a circle has a center at some point hk, and the radius, or the distance, from hk to any xy point on the circle is a constant, then we can say that the radius equals that distance from any xy to hk, and r squared equals x minus h squared plus y minus k squared. I hope that you remember that a circle whose centered at the origin is x squared plus y squared equals r squared. So we've just taken our hk shifts here, and we've related it to the distance formula to get the area of, or the equation for any circle with a center at hk and a radius of r. So that's how the distance formula relates to the equation of a circle. This is called the standard equation. This form is the standard equation of a circle with a center at hk. So very simply, we want to do some work here. So let's say that we want to find the equation of a circle whose center is at 2, 3 and has a radius of 7. So using my x minus h squared, y minus k squared equals r squared, all I have to do is plug in x minus 2, that's my h, y minus 3, that's my k, equals 49. Simple enough. Do a quick one for me. It'll be example 1. Example 2, do a circle whose center is at 2, negative 4, and that has a radius of 3. So again, that's going to be x minus 2 squared plus y plus 4 squared minus a negative 4 is plus 4 equals 9. So that's all we have to do to write equations of circles. The question is, and I think we'll come back to it, how do we put this into a calculator to graph it? But we'll come back to that. General form of a circle. x squared plus y squared plus dx plus ey plus f equals 0. You can see that there are no coefficients on the x squared and y squared, so we're going to assume they are 1. If we had different coefficients here, we would get an ellipse, not a circle. And that's called the general form. Now, if I give you an equation and we want to write it into general form, so example, if I give you x plus 3 squared plus y minus 2 squared equals 6, and I want you to write that from standard to general form, all you have to do is expand. So turn off the video and do that on your own. So we get x squared plus 6x plus 9 plus y squared minus 4y plus 4 equals 6. Looking at my general form, I'm going to put the x squared, y squared first, then the x term, then the y term, then all of my constants. So I've got 9 plus 4 minus 6 gives me plus 7 equals 0. And that's the general form. So going from our standard form to our general form is pretty easy. But what about going the opposite direction? Oh, sorry. And let's forget about this for a minute. I should have put another blank screen in. Let's say I give you this equation, x squared plus y squared plus 4x minus 6y minus 23 equals 0. And I want to change this to my x minus h squared, y minus k squared equals r squared, because that's much easier to graph. In order to get into this form, I need to use complete the square. So I'm going to put my x's together. Remember, we need a blank there for complete the square. And then I've got y squared minus 6y plus something will give me a positive 23. And remember, if I'm going to add to the left, I've got to add to the right. So do you remember what goes in here? We take half of the middle number and square it. In this case, 4. Half of the middle and square it. In this case, 9. So I'm going to add 4 and 9 to this side, since I added 4 and 9 to this side. Now I can go back and factor. This would be x plus 2 squared, y minus 3 squared equals 36. So you can see that I have a circle with a center at negative 2, 3, and a radius of 6. Simple enough. Now, let's go back to this equation and see what we can do to put it onto a graphing calculator, or as I wrote, calculator. So, graphing calculator. In order to change this equation to something that can go into a calculator, remember with your calculator you need y equals. So there are a couple of ways to deal with this. I can say that this is, and let me erase some of this, a quadratic in terms of y. In other words, we have y squared minus 6y plus x squared plus 4x minus 23 equals 0. Now I'm used to seeing y squared plus y plus a constant, right? Ay squared plus by plus c. Usually we have an x there, but we're doing it with y, because I want to set a y equals. So if that's set equal to 0, I can use the quadratic formula. But if you look, all of this is my c value. So y equals negative b, negative of negative 6, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Now I've got a plus or minus here, so I'm going to enter this in my calculator. Y sub 1 is going to be 6 plus the square root of 36 minus 4 times x squared plus 4x minus 23 over 2, and y sub 2 is going to be 6 minus all of this. So I can enter those two equations into my y sub 1 and y sub 2 to get a circle. Or if I change this back to the standard form that I got, I can simplify this in terms of y by saying y minus 3 squared equals 36 minus x plus 2 squared. I can take the square root of both sides, and I can add 3. And if I put those in again, my plus as my y sub 1 and my minus as my y sub 2, I will get the same circle out of the graphing calculator. Take a moment and try to enter these into your calculator and see if you can get it to make a circle. And we will practice this in class as well. So that's the end of section 1.9.